Welcome to this lecture or this session. In the last lecture, we have discussed about the derivative of the functions using the method of first principle. And we have also discussed that we will find out the derivative of three different kinds of functions. One, algebraic, two, exponential, and third is logarithmic. So in the last lecture, we have discussed the derivative of algebraic functions, that is derivative of x raised to the power n. And this is what? It is nxn minus 1. And I have told you x raised to the power n is the function which will give you the derivatives of all algebraic functions, right? So next stage is differentiation of the remaining two kinds of function, that is exponential function and logarithmic function. So in this lecture, we will start our content by taking the derivatives of exponential functions, right? So there are two functions whose derivatives we will calculate. So the first thing is what is exponential function? Exponential functions are those functions which are in the exponent of a constant a or e. Any function which is in power of a constant a or in power of e. A is any number, right? But here e is a constant. You know that e is a specific constant whose value lies between 2 and 3. So this is what we will determine all kinds of exponential functions. See, a raised to the power x, e raised to the power x, right? If fx is equals to e raised to the power x, this is e raised to the power x and this is a raised to the power x. If fx is given as e raised to the power x exponential function, then its derivative remains the same, right? This means what? This is the only function whose derivative never changes. It remains the same. But if fx is equals to a raised to the power x, a is any constant, right? Then its derivative is a raised to the power x log a base e. These are the two formulas which we will use to find out the derivatives of all exponential functions, right? So one formula for algebraic xn and these two formulas for exponential, and the next is logarithmic differentiation. Logarithmic functions are those functions which comes with log, right? Base may be e, log of e base x and log of x base e, right? We can have two kinds of function, log of x base e. If base is not mentioned in any question, we will assume that the base is e. Otherwise, the base will be mentioned. Be careful, okay? Let me repeat it once. If the base of the log is not given in any question, then its base is always considered as e. Otherwise, it will be mentioned. Okay. So there are two basic functions as usual in case of logarithmic functions also. One is if fx is equals to log x base e, then its derivative is 1 upon x. And if fx is equals to log x base a, then its derivative is 1 upon x log e base a. So likewise, exponential functions, we are also having two formulas to find out the derivative of all logarithmic functions. And you all know that the logarithmic and exponential functions are inverses of each other. This we should also keep in mind. That is why we were having two formulas for exponential and the remaining two formulas for the logarithmic functions. So the total number of formulas which you will have to remember, they are 5. One x raised to the power n for algebraic function, two formulas for exponential. One is e raised to the power x, second is a raised to the power x. And the remaining two for logarithmic functions, one is log x base e and other is log x base a. So total, all the 5 formulas are more than sufficient to find out the derivatives of all the 3 kinds of functions, algebraic, exponential, and logarithmic, right? Let us take some examples further. So before proceeding the examples, there are some basic rules of differentiation. These rules are known as rule number 1. The differential coefficient of a product of a constant and a function is equal to the product of a constant and differential coefficient of a function. This means what? If fx is any function and say k is any constant, k is multiplied with x, right? So its derivative, when we will calculate its derivative, this k will remain as it is. We will find out the derivative of the function only, right? This is rule 1. Rule 2 is what? If two functions, I have told you the functions behave like numbers. If we are having two numbers, we can add up, we can subtract them, we can multiply them, and we can divide them. So if we are having two functions, we can add up, we can subtract them, we can divide them, and we can also multiply them. If two functions are given, say fx plus gx, right? And we want to find out its derivative, say d over dx of the sum of two functions. This is equal to d of dx of fx plus d of dx of gx. What does it mean? The derivative of sum of two functions is equals to their derivatives separately. Likewise, if we are using the minus sign in place of plus sign, the result will be same, minus here, and we will get here minus here. This means fx minus gx, the difference of two functions is given, and you want to find out its derivative. So its derivative is always equals to derivative of fx minus derivative of gx, right? Now let us take some examples. Now we all discuss 5 standard formulas to find out the derivative of all the 3 kinds of functions. Now in any question we can have any kind of function. So you should be mentally prepared to use any one of the 5 formulas known to use in any particular situation. But before proceeding for the numerical questions, let me clear one more thing. Say if I write you x power 3, take the example of the first formula x raised to the power n. You want to calculate the derivative of x power 3. Its derivative is by the formula 3x power 3 minus 1, right? Into, be careful, derivative of, this is very important, x. This is the complete formula. So see what happens, 3x power 2 and derivative of x is 1. So derivative of x is 1, that's why we don't write it, right? Be careful. You should remember this thing. Let me repeat. X power 3, this is equals to what? 3x power 3 minus 1 by the formula into derivative of x. But derivative of x is 1, therefore we don't write it, right? So be careful. Likewise, if we are having e raised to the power x, its derivative is what? Its derivative is e raised to the power x into derivative of x. And since the derivative of x, so we don't write it. Likewise, the third is log x base e. Its derivative is 1 upon x into derivative of x. Again, derivative of x is 1, that's why we don't write it. So what I want to explain before you, try to understand the technique or the trick. For example, all these formulas which we have discussed, they are given for x. If x is replaced by any other variable, then the formula will remain the same, but the derivative will also change. For example, if I take here e raised to the power 2x and we want to find out its derivative. So look at here, by the formula, derivative of e raised to the power x remains the same. right? So use here e raised to the power 2x, its derivative will remain e raised to the power 2x into derivative of x. Here we are having x, so we are using derivative of x. But here we are having 2x, so what we will write here? Derivative of 2x, right? Now, what is left? E raised to the power 2x into derivative of 2x is 2. So 2 e raised to the power 2x is the derivative of e raised to the power 2x. Should keep in your mind. Is it clear? Let me explain once more so that you should clear this technique. This is very important. Generally, students forget it. That's why they commit mistakes during the solutions of the various questions. If I take y is equals to e raised to the power 5x, for example, then find out its derivative dy over dx. By the formula of the exponential function, the formula says e raised to the power 5x into derivative of 5x, because here in place of x we are having 5x. Formula is what? Y is e power x, then its derivative is e raised to the power x. Here we are having e raised to the power x, but in formula into derivative of x we don't write because derivative of x is 1. So whenever x is being replaced by any new variable, then the derivative of that variable should be also written, right? Here x is being replaced by 5x, so the formula is what? E raised to the power 5x into derivative of 5x, that is what? E raised to the power 5x into derivative of 5x is 5. So derivative of e raised to the power 5x will come out to be 5 into e raised to the power 5x. This is true in all the 5 formulas because all the 5 formulas are given for x if x is being replaced by x power 3, for example. The derivative of x3 is not 1, right? So be careful. We will use this technique in the subsequent questions to make you the things clear, right? Let us take some examples. Find the derivative of each of the following functions with respect to x, right? If y is equals to, if x is equals to 3 upon 5, you know 3 upon 5 is a constant, a number alone, and its derivative should be 0. So its derivative is 0. So if fx is 3 upon 5, then f dash x is equals to 0. Use f dash x or d upon dx of 3 upon 5, same thing. You can also write simply like this. Fx is 3 upon 5, then f dash x will be equals to 0. That's all. This is your solution. Now take this one. Fx is equals to 2x square plus 15x plus 20. So this is C. This is function 1, this is function 2, this is function 3. This is sum of 3 functions. And just in the earlier slide, what we have done, if 2 functions are added, we can find out its derivative by getting their derivative separately. Here 3 functions are added. We can find out the derivative of sum of 3 functions by getting its derivative separately, right? So fx is this, then f dash x means derivative of this plus derivative of this plus derivative of this, right? The same we did here. F dash x is d upon dx of this, right? This means what? Derivative of the first term, derivative of the second term plus derivative of the third term. Now, look at here, see d upon dx of 2x square. Find out its derivative. I have told you 2x square. The number 2 is multiplied with x square. X square is a variable, so its derivative will be what? 2 will remain as it is. And derivative of x square by using the formula of x raised to the power n. X raised to the power n is what? Nx n minus 1. Here n is 2. So what you will get? 2x2 minus 1. So you will get here 2 into 2, 4. X power 2 minus 1, that is x. So derivative of x square is 2x. So 2 into 2, 4x, right? This is 2 into 2, 2x. Now 15x. So 15 of x. 15 is a constant and derivative of x is 1. So this is 15. And 20 is a constant. So derivative of a constant is 0. So what is left? 2 into 2, 4x plus 15 into 1, that is 15. Derivative of x is 0 because, say, y is equals to x. Use the formula of x raised to the power n. dy over dx is what? X power 1. So this 1 will come here. 1 into x power 1 minus 1. So what is this? X power 0, and x power 0 is 1. That is why the derivative of x is 1. Right? Now take this one also. Fx is equals to this, x power 4 minus 7x cube plus 15 upon x minus 5 upon x square, right? This is 4 functions. This is first, this is second, this is third, this is 4. Now find out its derivative by taking derivative of all the 4 functions, right? If fx is this, then f dash x is what? X power 4. What is the derivative of x power 4? Now I have written it directly because this is not the first exercise. What is the derivative of x raised to the power 4? Think over it before I am proceeding. X power 4 by the formula of x power n, 4x4 minus 1, that is 4x power 3. This, right? 7x power 3. 7x power 3 means what? 7 will remain as it is. X power 3. Use this formula x power n again. 3 x power 3 minus 1. This is what? 7 into 3, 21 x power 2, right? 7 into 3 x square, right? 15 upon x. Oh, this is good. How you will find out the derivative of 15 upon x? I have told you x power n, n is positive or negative. So if you transfer this x from dr to nr, what you will get? 15x power minus 1. Here n is minus 1. Apply the formula of x raised to the power n. See what will happen. 15 minus 1 x power minus 1 minus 1. What you will get? 15 into minus 1 minus 15 x power minus 2. Write it like this, or this can also be written as minus 15 upon x power 2. So we are getting this. And finally, 5 upon x square. In the similar way, transfer x square from dr to nr and then apply the formula of x raised to the power n. Let us take for a while 5 upon x square. This can be written as 5x power minus 2. So this is equals to what? 5 will remain as it is, minus 2. X power minus 2 minus 1. So what is left? 5 into minus 2, this is minus 10, x power minus 3, and this can be written as minus 10 upon x power 3. This minus is there, so minus minus we will get here plus, right? So this is how we can find out the derivative of such functions using these 5 standard formulas. Now differentiate. Next example, differentiate each of the following functions with respect to x. Now we have overall 5 formulas to find out the derivatives of all the 3 kinds of functions. So naturally, if we are calculating the derivatives of 3 kinds of functions, any function can appear in any question, even more than one function can appear, or even all the 3 functions may appear in a single function. See here, this is your function. X power 5 is algebraic, e power 2x is naturally exponential. So this is your fx. So its derivative is derivative of this plus derivative of this plus derivative of this. Very simple, right? So derivative of x raised to the power 5, x raised to the power 5, derivative will be what? 5x power 4. Now I think I should write it directly, right? 5x power 4. What about 3e power 2x? So this 3 will remain as it is. Now look at here. We know the formula of e raised to the power x, and its derivative is e raised to the power x into, as I have told you, derivative of x here. Here we are having e power 2x. In place of x, we are having 2x. So what we will use? This 3 will remain as it is. E power 2x into derivative of, I am writing here it completely, derivative of 2x. Now what you will get? 3e power 2x into derivative of 2x is 2. So 3 into 2, 6 e power 2x, right? So this is what we will get here. Now, similarly, you can take this one, this example. Let y is equals to ax square plus bx plus c divided by root x. Now, find out its derivative. See, a, b, and c are constants, right? X is the only variable here. So, first change this function. This is what? Ax square plus bx plus c divided by root x, right? So see, we can write it like this: y is equals to ax square divided by root x means x power 1 upon 2 plus bx x power 1 upon 2 plus c divided by x power 1 upon 2. Clear? No problem. Now transfer this power 1 upon 2 from dr to nr. What you will get? Y is equals to ax square into x power minus 1 upon 2 plus bx into x power minus 1 upon 2 plus c x power minus 1 upon 2. When two numbers are multiplied, their powers are added. So what you will get? 2 minus 1 upon 2, what you will get? 4 minus 1 upon 2, that is 3 by 2, right? So what you will get here? Y is a x power 3 by 2 plus b. Here x power is 1 and here x power is minus 1 upon 2. So 1 minus 1 upon 2, what you will get? X power 1 upon 2, right? And this will remain as it is, c x power minus 1 upon 2. Now find out its derivative. You know, here n is 3 by 2, here n is 1 by 2, here n is minus 1 by 2. So by using the formula of the x raised to the power n, see, write it here, dy over dx will be what? A will remain as it is, x power 3 by 2. So this 3 by 2 come here, x power 3 by 2 minus 1. What is left? This will be equals to a into 3 by 2 x power, what is left? 1 by 2. So this is equals to what? 3a by 2 x power 1 by 2, the same as we get here. Similarly, you can calculate the second term, its derivative, and third term, its derivative. See, try to find out the questions yourself. Please remember one thing, in mathematics, it is not important what I am solving here. The important is what you will attempt yourself. That is the learning process. You cannot learn mathematics until you will not practice yourself. So try to find out the solutions of the same questions or the questions which are resembles with what we did here, so that you may develop a confidence and would be able to solve the questions yourself, right? Let us take this example also. Find the derivative of the function 1 plus x square plus 1 plus x square plus x cube plus x4 up to x power 50 at x is equals to 1. This is what? This is a sum of functions 1 plus x power 1 plus x power 2 plus x power 3 up to x power 50. So first find out its derivative at x is equals to 1. Whatever derivative you will obtain, final, put x is equals to 1. That is the meaning of derivative at x is equals to 1. See, come here. This is your function. Fx is equals to 1 plus x square plus x cube plus x power 50. We are adding the terms from 1 to x power 50, right? Then f dash x, this is 1, derivative of 1 is 0. This is x, derivative of x is 1. This is x power 2 by the rule of x raised to the power n, its derivative of 2x. x3 by the rule of x power n, x derivative is 3x square. Likewise, x power 50, its derivative will be what? By using the formula of this, that is 50x 50 minus 1, that is 49. So this is the loss, right? This is your f dash x. What you want to calculate? This is derivative, simple. And you have been asked to find out the derivative at a point x is equals to 1. Now put x is equals to 1 in this derivative. Now if we put x is equals to 1, what we will get? 1 here, 2 into 1, 2, 3 into 1, 3, 50 into 1, 50. So 1 plus 2 plus 3 plus 4 plus 50. And this is what? This is the sum of first 50 natural numbers. And at your earlier classes, 9th or 10th, you know the sum of first 100 natural numbers, first n natural numbers is given by n plus 1 by 2. What is n here? N here is 50. So the formula is what? 50 into 50 plus 1, 51 divided by 2. Simplify it, you will get 1275. Right? So the value of the derivative of the function at x is equals to 1 is coming out to be 1275. Take this one also. We are given y is equals to 1 plus x upon factorial 1, x square upon factorial 2, and then so on. Show that dy over dx is equals to 1. So dy over dx is equals to 1. This type of questions we will get a number of times in our subsequent text. So there are three ways to find out the solutions of such type of question. Number one, take the left hand side, substitute the values, simplify it, and try to obtain the right hand side. Case 2, take the right hand side, substitute all the values, and simplify it, and try to obtain the right hand side. And in some cases, we take the left hand side, solve it, and take the right hand side, solve it. Both sides should be equal, then the solution has been achieved. So these are three ways which we can use to find out the solutions of such type of questions. So here we are given what? We are given y is equals to 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3, and then so on. We have to show that its derivative will remain y itself, that is y. You know about the factorial. Factorial of 3 means what? 1 into 2 into 3. Factorial of 5 means 1 into 2 into 3 into 4 into 5. So factorial of any number is what? The product from 1 to that number is known as its factorial. So y is equals to this. Now find out its derivative. So dy over dx is derivative of 1, derivative of this, derivative of this, derivative of this, derivative of this. And they all can be differentiated by using the single formula of x raised to power n. Right? See, derivative of 1 is 0. No problem. Derivative of x upon, this is factorial 1. Derivative of x is 1. So what we will get? 1 upon factorial 1. And factorial 1 is also 1. So 1 upon 1 is 1. 1 upon factorial 1. X square, derivative of x square is 2x. 2x upon factorial 2. So we are getting this. X cube, 3x square upon factorial 3. X4, 4x cube, 1 factorial 4. Right? This line is okay. Now in the next line, 1 upon factorial 1, you will get 1 here. 2 and 2 will cancel out. What is left? We will get x upon factorial 1, because factorial 1 is always equals to 1. Same thing. Here 3, this is 3 and this is factorial 3. So how we will solve it? 3 and factorial 3 is 3 into 2 into 1. 3 and 3 will be cancelled out. What is left? 1 upon 1 into 2 is factorial 2. So what is left? X square upon factorial 2. Similarly, here we will get x cube upon factorial 3. So see, this is what? This is the same. 1 plus x square. Look at this. 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 plus x4 upon factorial 4. And this is equals to y. Right? So I think you will understand the concept of derivative and the formulas, especially 5 formulas which we have used or which we have explained to understand how we can use these 5 formulas to find out the derivatives of the various kinds of functions. I think I should stop it here. So students, thank you very much for your patience learning. Thank you.